The oceans, seemingly limitless, invoke in us a sense of awe and wonder, and also sometimes fear. They cover 70% of the surface of our planet, and yet they are still the least explored. We've also recognized an uncomfortable fact. The health of our oceans is under threat. They're changing at a faster rate than ever before in human history. In this first episode,
aquaculture is the rearing of aquatic fauna or cultivation of algae and other aquatic plants. The oceans have always been seen as a vast resource with unlimited fish, but overexploitation has left natural fisheries depleted or even completely destroyed. This, combined with a larger human population with increased demand for fish, has driven the aquaculture industry to grow at a rate of 0.5% yearly, with aquaculture responsible for roughly 40% of global fish production and 2% of global food production. With many natural fisheries close to or already completely depleted, aquaculture may take the pressure off of natural fisheries and the fish which are found in them. Up to 90% of large fish, including swordfish, marlin and sharks, are now wiped out because of overfishing. Aquaculture has been highly successful with several species, including bream, salmon, trout, mussels and certain seaweed species.
Aquaculture is one of the fastest growing industries in the food sector for global food production. However, aquaculture poses many ecological threats, including bacterial and viral disease, through the rapid spread of pathogens, especially in farmed salmon and shrimp populations. The release of antibiotics into the watercourse also causes problems through gene transfer of antibiotic resistance into viruses in the wild. The increased competition between released farm fish, wild fish and hybrids cause competition for food and habitats. Finally, the depletion of wild fish population densities due to harvesting for fish meal also poses a threat.
Raising fish within hatcheries results in hygienic shortcomings and increased outbreak of various aquatic diseases due to increased crowding, lack of sanitation barriers, and failure of hatchery managers to isolate infected populations quickly. Stress is placed upon fish within the hatcheries, decreases the efficacy of the immune systems to fight bacterial infections. Therefore, the use of prophylactic or antimicrobial antibiotics has been increasing across the aquaculture industry. Global losses because of aquaculture-related viral diseases have been known to equate to $3 billion. Firstly, let's talk about an example of viral diseases that have emerged because of shrimp aquaculture. Shrimp aquaculture has become a huge global industry over the last few years to meet consumer needs for seafood, and it's greatly contributed to the socio-economic development across Asia. But what are the consequences of this? In the 1980s, a plethora of unidentified viral diseases emerged in populations of farmed shrimp, having devastating effects on production as they rapidly spread across international boundaries. White spot syndrome virus, or WSSV, is a viral pathogen that by far has the most devastating effects on farmed shrimp. It's considered most responsible for global production losses within this species. It causes 80 to 100% mortality within 5 to 10 days of infection. The use of antibiotics within aquaculture to mitigate spread of disease is causing increased antibiotic resistance within the wild. This is due to leaching of undigested antibiotics being flushed into the sea. Not only are viral fish pathogens acquiring antibiotic resistance from this, but terrestrial and human pathogens are also acquiring resistance genes via horizontal gene transfer. This is a major concern for public health.
Just a little farther, that's it! I am truly going to vomit! Voila! All right, gang, good work.
Look, Flo, we made it.
You won't have any more problems from here on out.
Escaped fish from farms have a severe effect on native fish, close to them or not close to them within the area. This is due to their small gene pool, their creation of hybrids from similar species of fish, and to outcompete some fish for food and territory within the area. Farmed fish have a very small gene pool. They are more likely to grow larger expand faster, mature quicker, and are more prone to take risks. These are favourable traits within the environment, so are more likely to be able to reproduce with native fish to create hybrids. The problem with this is the gene flow is reduced because the gene pool within farm fish is very small compared to native fish. This makes them more prone to illness and diseases. These hybrid fish have been shown to be very aggressive in nature, taking territory and dietary requirements from native fish, outcompeting them, and the population in native fish end up dwindling. This has been shown in many studies, but most importantly in Atlantic salmon, which have a huge impact on aquaculture all over the world, especially in Asia. Some fish that have escaped have created hybrids, and the hybrid population has ended up increasing to the point where there are more hybrids than native population in the environment. People are concerned if this continues within the area, there will just be hybrids and no native species available, reducing the gene pool of the whole species and ending up, as a result, all fish in the area dying. But other fish within the area are affected too, not just ones that are similarly related to them. They are outcompeted for food and dietary requirements from the hybrid fish. These also make the native fish dwindle in population as they cannot sustain a larger population to survive.
Aquaculture is having an unexpected effect on fish populations in recent years. With the current increase of carnivorous fish farms comes the need for more fish-based food. Carnivorous fish such as salmon, shrimp, sea bass and groupers all require 20 to 40% fish meal in their diet. The fish required to make fish meal for aquaculture purposes comes from wild-caught fish. These are mainly lower trophic level species such as sardines, anchovies and mackerel. Almost half of all fish caught are now consumed by aquaculture, leading us to ask the question, does aquaculture provide a net gain or net drain on the world's fish supplies? The relative efficiency of fish farming is extremely hard to quantify. This is mainly due to the energy transfer between trophic levels in the marine environment being poorly understudied. However, with recent advances in technology and aquaculture management, the food conversion ratio is improving, though are these improvements happening fast enough? Continued growth of the aquaculture industry could exceed the current supply of fish used for fish meal production, potentially jeopardizing the industry's economic sustainability. Not only would the aquaculture industry be under threat, but the fish populations supporting aquaculture will deteriorate too. And finally, removing lower trophic level species from the marine environment will obviously have profound effects on the wild predators that feed upon them. This includes commercially valuable species, marine mammals and seabirds, all of which are tremendously economically and culturally valuable.
To summarise, the aquaculture industry has provided a means for socio-economic growth in many countries and has provided an alternative method to meet consumer demands for seafood. However, ecological risk associated with the industry are a cause for concern, and management of fisheries to reduce public health risk and promote species conservation needs to be assessed.